Hi everyone, I'm Andrew. I'm a consultant here at Thorogood. I've worked on a range of BI and analytics projects across our portfolio of clients, and some of those touch right under this topic, whether that's taking one project, taking analysis that already existed, and then automating that, and then other projects creating early stage proof of concept projects that always with a view to roll them out globally and present them to businesses across multiple markets. So today I'm going to talk you through productionizing enterprise analytics. So we're looking here really at how you can get the most value out of your analytics investments by allowing them to be scaled out within your organization. Now, for those of you who aren't maybe so familiar with Thorogood, we're a BI and analytics consultancy. We focus on business objectives, and we work with various technologies to help meet those objectives. So you can see here an example of some of our technology partnerships along the right-hand side. And we provide end-to-end services ranging from helping to shape your vision and strategy through to full implementation of bespoke applications and providing the training and ongoing support for those applications. We're a global company, and we work with customers around the world, and it's quite common that we'll work with consultants in each of our different offices on any given project. And I want to start off this webcast by talking you through sort of what a typical analytics project lifecycle looks like. And at Thorogood, we like to use the CRISP-DM model to look at that. Now, for those of you who aren't familiar with it, this is an industry standard model that for running analytics projects, and it's actually very intuitive in terms of the various steps that it covers. So you'd look to start off with a business case for conducting some analysis. You're looking for a thorough understanding of the business environment and the requirements and the question that you're trying to answer, really. Once you've got that business understanding, you then look at the data that you have available. You assess the data. Is that sufficient to meet your needs? And then you progress on to the data preparation and prepare the data for analysis. You develop your models, and once the models are developed, it's important to evaluate their suitability in meeting those original business needs. Once you're happy with the models, the aim then is to deploy them so that the whole business can use them. Now, as you can see, this isn't just a linear process. There are arrows going back and forth in this diagram, and that points to an analyst moving back and forward between the different steps, and you'll continually assess the suitability both of the data and the models in meeting those end business goals. So in some cases, you might even start again from the beginning as the business questions are clarified or as new business questions arise out of the analysis that you're doing. And it's a process that analysts and data scientists should be very well versed in when they're achieving good analytical models. But what we're going to focus on today is mainly on this last step, this step deploying and productionizing analytical insight into the business. And this is a step which presents a wide range of challenges if you're trying to do it really well. So why do organizations struggle with this deployment step? I'm going to point out three contributing factors here, and all these three really play together to exacerbate one another and cause a few problems. Firstly, there's likely to be some knowledge gaps with the analysts. Typically, you'll take on analysts who have great statistical and modeling experience, but not necessarily having the technical or software development background to progress the good models that they build through to that enterprise level that we're looking for. Or it may be the case that they think they have the required software development skills and are able to come up with some innovative solutions which work well in isolation, but actually they're not going to scale up well to the required scale for the enterprise. The second challenge, there are a great number of options to choose from. More and more vendors at the minute are introducing analytical capabilities into their products. So it's not only questions around which vendors you want to use in productionizing analytics, but actually it now even goes down to the level of what type of product you use, or whether that's front-end tools, is it databases, is it cloud offering that you need to be looking at. And there are a great number of options and a great many choices to look at. And thirdly, all of these technologies are evolving very quickly, particularly at the minute the cloud-based technologies are developing at an incredible speed. And it's difficult for any individual developer to keep up. And so many organizations worry about, what are the choices that you're making now? Will those choices still make sense in a year's time or in 3 years' time? And these three challenges really play together into creating this problem around productionizing analytics. Now, to help break this problem down, I want to talk you through 3 stages of analytics productionization that many organizations will find themselves moving through, and hopefully you'll be able to identify with some of these. And you'll see, as you move through the stages, it becomes easier for analysts and data scientists to get their work out there to the wider business, and that's always what you're aiming for. The first scenario we'll touch on is that of a lone data scientist working largely in isolation from IT, or potentially a team of data scientists, but all applying their own expertise in this way to some business problem. Now, in this scenario, there's often little oversight, and everyone has their own way of working. That's going to lead to a large amount of variability between the methods of, for example, data acquisition and processing, and parts of the work will probably be unnecessarily slow. One step on from that level, we have a more structured environment where analysts have the appropriate tools provisioned by IT to handle the more heavy compute requirements of analytical methods, as well as appropriate access to the organization's data to ensure that all the good work the analysts are doing is based on the one version of the truth rather than potentially inaccurate, manually maintained data from a number of sources across the organization. And then finally, the third level we'll take a look at is a thought-out, scalable and streamlined framework for developing and productionizing analytical insights, which are going to allow the analyst to make the largest impact with their work, and also be flexible to new technological advances in the future. So the first of these 3 stages has several defining aspects. First of all, typically lots of work will be done on local machines. Now, at first that seems quite convenient, but both R and Python, which are common tools for data scientists to use, run in memory. And so limited resources in the local machine can quickly become a bottleneck, with analysts developing increasingly compute-heavy analyses. And into this stage, the time starts being wasted waiting for models to run as you're waiting for those compute resources to become available. Now, we were working with a client recently, to give you an example, where someone had developed a model that took 2 days to run, and that was running for one particular country and one product category. And the plan was to take that model and scale it out to nearly 200 of that kind of country category combination. And clearly something's going to need to change in that scenario, because if you take something that takes 2 days, you've got to run it 200 times. That's not going to scale out on that same local machine to run across all of those examples. Secondly, data is often acquired on a very ad hoc basis. That might seem okay for a proof of concept, but it's very common not to question the reliability of the data. Certainly, you need to check that the data you're using in anything long-term is going to be completely robust, and it's going to be coming from an organization's verified data source. And again, this creates some challenges when you start to replicate the analysis out from doing it just once as a proof of concept. Once you want to apply the same analysis in different scenarios or on a repeated basis, you need to make sure that the data is coming from the right place. Another challenge of this kind of free-for-all style environment is a lack of consistency between analysts. Each person individually is probably doing excellent work, but when you combine it all together, it becomes quite challenging to implement and manage solutions which are each using a different approach, for example, for data transformations, or for the output presentation, or even just looking at things like coding standards across the organization. And then often there's little discussion with IT beyond the kind of necessary request to have software installed. Now, without that dialogue, that doesn't give IT the opportunity to understand the different needs of the analyst or data scientist compared to perhaps a typical business team member. And it doesn't allow analysts to get insight into what their options are for making life easier. And essentially what happens here is you end up with a lot of people thinking that they're always doing one-off pieces of analysis, but actually once the business stakeholders see it and see the value of those analyses, they want it replicated, for example, in other regions. And that then leads to a real struggle to meet the expectations and get that solution up and running as fast as possible. And unfortunately, the message here really is, if you don't sort out the platform initially, most likely at some point you're going to struggle to productionize. The second case, the second stage, is to put in place a structured development environment, both in terms of tools and practices. And the aim here is to save time and ease the move to a production-ready solution. So what we need to do here, we need to give analysts appropriate tools for their needs. So that might mean a dedicated R server that they can all connect to. It might mean a cloud-based Hadoop or Spark cluster with something like R or Python running, and that would allow them to scale out when required for running a model. It might even mean something like giving them access to centralized graphical processing units to allow them to develop sophisticated deep learning applications as and when required. It also means working out where and how analysts should be connecting to the data that they're using. For building an analysis, you need to ensure that data is coming from a trusted and a valid source. You're also going to want to make sure that any use by analysts isn't going to impact existing reporting systems, for example. You also want some level of coordination between members of the data science team that will allow you to ensure that everyone's following common standards for the modeling itself, but also in terms of both the data preparation and any documentation that you're taking of the decision you're making. And this might involve the use of a standard project workflow with template files, for example, for the different stages that we talked about in CRISP DM. There are various ways that you can organize and group the documentation that's needed in the process. And as you can imagine, you'd want to establish a fairly strong dialogue between analysts and IT so that you're having conversations about both technical infrastructure and the data that's needed, and make sure, for example, you have a chance to agree the times of day where certain data sets are available to connect to. And then the third case, the final stage, we're going to look at an analytics framework, and this includes really automating the analytical processes that fit within the wider data strategy. Here we want to automate both the processing of the data required for analysis, and we want to schedule and automate the algorithms and analyses themselves. And I'll talk a little bit more about the second of those points in a moment, but in terms of data processing, we see analysts often develop their own cleaning and transformation code in R or Python, and that might be fine for proof of concept, but here we're thinking more about moving into production. And in order to optimize that, we might need to look to move away from building in R and Python. You're also going to want to focus on ensuring that productionization processes and projects involve all three of business, IT, and the analysts. Here we're trying to make sure that it's technically realistic and that it's been well thought through and that it's really going to meet the needs of the business when it's delivered. Finally, your organization is going to want to agree on a certain stack of technologies that they'll utilize, at least by default. But with this, you want to build in enough flexibility that you can change that list of technologies as the market progresses, or as new use cases arise and you see the need for novel solutions to develop. This last point highlights one reason why cloud technologies such as Microsoft Azure or Amazon Web Services actually work really well for this kind of analytics productionization. And in addition to their immediate flexibility in being able to scale out as required, with those cloud technologies you pay for usage rather than potentially hefty upfront infrastructure costs, though of course there is always some cost in terms of time and effort to set something new up. Nevertheless, the cloud technologies are pretty good if you don't want to tie yourself down, and they give you an opportunity to experiment with new technologies as you see uses for them and as they become available. Now, as I mentioned, a big part of this final stage is looking for the ability to automatically run models and analyses periodically. To take one example, imagine as an organization you're trying to identify products which your existing customer base would be interested in. We can do that analysis based on past behavior and purchases, and you might respond with some sort of example advertisements, encouraging that customer to buy certain products which they haven't previously. Now that's an initial analysis that you might conduct on one set of data, but you can see that once you've identified the different purchasing habits and behaviors and how those lead you to the interest in new products, you're going to want to apply this analysis, do it repeatedly, say once a week, once a month. You're probably going to want to scale it out to more countries as well, and you want to make this analysis repeatable. One way to facilitate that kind of scheduling is to deploy the analytics within database. That will allow you to both read directly from the data itself at the source, and it will allow you to put a schedule in place. Now, more and more vendors are building in this capability. So, for example, Oracle and Microsoft have both got pretty strong options for combining R with the database itself. And that provides the capability to run R and Python code within SQL databases of various flavors. You're then able to use R to take the data from SQL, write it back into the SQL, and then you can point your usual reporting tools at the database in the way that you usually would. And it means that those analyses can be computed using R or Python, but all of the output comes through the same combination of tools that you're using for all of your reporting. Another option is to deploy your analytical code to the cloud. So here you might look to something like a Hadoop cluster with Spark and R or Python. Both Microsoft and AWS will facilitate this pretty well with something like Azure HD Insight or AWS Elastic MapReduce. And here you can use the tools that the cloud vendors develop themselves for scheduling analytical workflows. So in the Microsoft Azure world, that would be something like Azure Machine Learning and Data Factory. So you've got a few different options for how you might do that in the cloud. What I want to talk through now is one example customer use case that we've worked on recently. The clients here were analyzing the sales behavior within a country and a category group of products. And they wanted to identify the characteristics of each grouping that would help them make planning decisions going forward. And here we use two environments, which follow the two of the later stages that I laid out earlier. So for the development environment, the decision was to use an Azure data lake containing verified organizational data that the analysts can then each connect to, whether they're using VMs with R installed or using something like Microsoft Azure HD Insight cluster with R and Spark installed. Now, every time new data was required, we were able to make it available to the analysts in the data lake so that they're always connecting to data in the same location and always connecting to data that's been verified. Once they moved to productionize the solutions, the landscape became slightly more involved. And in this case, data is sourced from the internal operational data store or from business-maintained data and CSV files. So those were manually maintained files which couldn't be automated. But again, we're getting the business to verify them before we load them into the data source. We then move the data from the sources into the Azure data lake using Azure Data Factory. And then the data cleaning and transformations were done in an Azure SQL database before being stored. The actual analysis itself was then done using HD Insight with Spark and R installed, with the results of the analysis written back to SQL. From the SQL database, we were then visualizing the results in Power BI. So you can see here that we've got quite a few different kind of combinations of software and infrastructure components involved with this one client. So the question that comes up really is, how do you pull all of this together successfully? Really, the most important thing is to put in place a framework. And that's something that you need to think out. You need to think through what your framework needs to be, and you need to think through what works for you. Although in the patterns and the examples before, I talked about the development environment and the productionized process as if they're separate stages. That doesn't necessarily mean they need to be separate in time or separate technologies. But it's important to think of having that development stage and that productionization platform and keep them logically in your head. Think about them separately. And think about them complementing each other in whatever framework you go with. Secondly, you're going to want to use the most appropriate tools and people for the job. And by doing this, this will enable analysts through appropriate technology and standards and make moving from proof of concept projects to full solution more manageable. One thing to think about here, R can do lots of data manipulation, and often analysts may be more comfortable with something like R than SQL, but it's not necessarily going to be scalable. And this is one place where you need different teams to work together to consider options like moving the ETL and data preparation steps into something that's more optimized for the job, something like SQL or perhaps SSIS. You also want to avoid analysts possibly getting frustrated by wasting time waiting for things to run unnecessarily. Think about the future. and think about what you're trying to achieve and choose tools appropriately. Each organization is going to have its own set of priorities and its own set of constraints when you're looking at this. But I've worked with customers, for example, who are only allowed to use the cloud, people who are pushed in that direction. I've worked with customers who aren't allowed to touch the cloud. Each organization is different, and that's going to make a difference to how your framework looks. Again, thinking about the future, don't productionize ad hoc solutions which aren't built to scale. If it's going to be impossible to replicate the analysis 10 times over for other countries or business areas, it's probably worth stopping and thinking through how you take that analysis and properly scale it out rather than just pushing it into an ideal production scenario. And finally, build effective communication between the business, between data scientists, and between IT. It's important to make sure that everyone in that group understands all of the objectives and the needs and the possibilities. So a few final thoughts as I wrap up. First off, we're living in a time with a wealth of technology and a lot of technological change. And there are a lot of technologies becoming available which make large-scale analytics possible for every organization. It's still important to stop and think about what's right for you. Don't just jump on every bandwagon available. And beyond that, it's really important to make sure that you're looking at the business applications. Think about the business questions and how it's actually going to drive value. Secondly, vendors are producing excellent products. There's a lot out there, but often vendors are going to see the possibilities from their own point of view. That doesn't mean that every approach they tell you is wrong, but again, think about whether the approach is right for you and your organization. Think about what your targets are, what's going to deliver value in your business, and what works well with the technologies that you've already got in place. Think about what you're trying to achieve. Again, the business questions, the why, the how. Don't just look at the analytics solution, but also look at the business question, and then alongside that, how you use technologies and practices to really achieve the business value from that. And think about all of these things together. Don't think about one of them in isolation with other bits left to other teams or organizations. Keep people working together. Keep the analysts, the business specialists, and IT all talking to each other and working out how to build the solution in a way that delivers value. Finally, it's really not a straightforward problem. There's a lot in this, and more of our customers are coming to us asking questions and asking for guidance. Don't be shy in reaching out if you think your organization could do with some help and advice. And with that, I'll throw up my email address. So feel free to reach out to me or any of my colleagues here at Thorogood if you've got any questions or anything you'd like to discuss on this topic. With that, thank you very much for your attention.